All right, let's get into it. Today, we're going to do a complete upgrade on your mental operating system. Seriously, we're going to toss out that buggy, outdated software our brains use for making decisions and install something way, way more powerful. We're going to install the probability mindset. And we'll start by looking at a fundamental flaw in how we're all wired to think.
So here's the core problem, right? Our brains are just obsessed with certainty. They crave it. But we live in a world that is anything but certain. And that creates this dangerous illusion that makes us judge our own decisions based on totally flawed logic. We think we're being super rational, but a lot of the time, our gut instinct is leading us completely astray. Okay, so this brings us to probably the most important question of all. What's the real difference between a good decision and a good outcome? I mean, they sound like the same thing, don't they? But confusing these two is one of the biggest mistakes we make, and honestly, it can have some pretty disastrous consequences.
And yeah, this example right here, it's a little intense, but it perfectly shows you the trap. On the left, you've got the decision to drive drunk, which is objectively a terrible, terrible decision. The probability of a catastrophic loss is just unacceptably high. But then on the right, you have the outcome. They got home safe. This is a classic cognitive error called resulting bias. They got a good result from an awful decision, and it was 100% because of pure dumb luck. So if we can't judge a decision by how it turned out, how do we judge it? Well, this is where we shift from thinking like an amateur to using the professional's playbook. We need a tool that can cut right through all the noise of luck and emotion. And this is the shift, right here. It's so simple, but so powerful. Amateurs are basically slaves to the outcome. They're the ones who would celebrate the lucky drunk driver. But professionals, they focus entirely on the quality of the decision itself, and they do it using a concept called expected value. Expected value, or EV for short, is basically the North Star of rational decision-making. The formula looks a little mathy, but it's actually pretty simple. You just take the probability of success and multiply it by how good that success would be, and then you subtract the probability of failure multiplied by how bad that failure would be. What you're left with is the true weighted average value of any decision you're considering. Okay, let's make this real. Let's use a startup job offer as an example. You know how it is. Everyone gets so swept up in the dream of the next big thing. But let's actually calculate the expected value of that stock equity. So that tiny 0.01% chance of a unicorn exit, that actually only gets you about $5,000 in weighted value. A slightly more likely 2% chance of a great exit gets you about $50,000. And as you can see, the overwhelming probability, almost 83%, is failure, which contributes absolutely zero. So if you add up all those numbers in that last column from the slide we just saw, you find out that all that exciting startup equity has a total expected value of about $70,000 a year. Now, let's say the startup is offering a salary of $120,000 on top of that. The total EV for the startup job is $190,000. And when you put that right next to a guaranteed $300,000 salary from Google, well, the picture becomes a lot clearer, doesn't it? And here's the punchline. The Google offer is mathematically superior by $110,000 a year in expected value. That startup lottery ticket feels exciting and romantic, for sure, but the cold hard numbers tell a very, very different story. Unless you've got some kind of inside information that dramatically changes those probabilities, the stable job is simply the better bet. But hold on. Is life really just about maximizing expected value in every single situation? Not quite. There's another critical layer we have to add on top of this, a rule that actually trumps everything else. Man, this quote just nails it. In the short term, you can make a perfect, positive EV decision and still get a terrible outcome. That's just luck, or what a statistician would call variance. The real key is surviving that short-term bad luck to get to the long term, because over a lifetime, the law of large numbers ensures that your good decisions will eventually win out. Which leads us to a really important question. Should we always, no matter what, try to maximize expected value? And the answer to that is a hard no. Absolutely not. And this slide explains exactly why, using the really stark example of Russian roulette. Look, if 100 different people all play one time, the group has an 83% survival rate. That's called the ensemble average. But if you play 100 times, your personal chance of survival, the time average, drops to 0. This huge difference between the group's odds and your personal odds over time, that's sometimes called the ergodicity gap. That's because Russian roulette contains something called an absorbing barrier, It's a state you can never ever recover from. Things like death, total bankruptcy, or complete reputational ruin. And the rule here is unbreakable. No amount of potential upside, I don't care how high the EV is, ever justifies a risk that can knock you out of the game for good. Survival always, always comes first.
Okay, so we've got expected value and we've got the #1 rule of avoiding ruin. Now let's tackle another huge mental bug, how we interpret all the evidence of success that we see around us every day.
So during World War II, the military studied the planes that made it back from their missions to see where they were all shot up with bullet holes. The obvious question was, okay, where should we add more armor to protect these planes better? What do you think? Where would you put the armor?
The answer, which is just brilliantly counterintuitive, is to add the armor where there are no bullet holes. But why? Why would you do that? Because the most important data was completely invisible. The planes that got hit in the engine or the cockpit, they never made it back. They were in a graveyard of evidence that nobody could study. And this is called survivorship bias. We do the exact same thing when we idolize billionaires who dropped out of college while totally ignoring the thousands and thousands of dropouts who failed. The question you have to burn into your brain is this: did the people who failed also do this? So let's put this all together now. We've talked about expected value, about avoiding ruin at all costs, and about survivorship bias. These aren't just a few clever tricks. They're the building blocks of a whole new operating system for navigating reality. And here are the core principles of your new OS. First, process over outcome. You've got to judge yourself on the quality of your decision, your EV, not on the lucky or unlucky result. Second, the golden rule. Avoid ruin. You have to survive the short term to get to the long term where your good decisions can pay off. Third, respect variance. You got to understand that in the short run, luck is a huge factor. Fourth, hunt for asymmetry. Look for bets where your downside is small and known, but your upside is potentially huge. And finally, detach your identity from your ideas. Your beliefs aren't you. They're just probabilities that you should be constantly updating with new evidence. And really, this is the ultimate takeaway. This whole thing isn't about finding some magic formula that guarantees success, because that doesn't exist. It's about a relentless, day-after-day process of just tilting the odds a little bit more in your favor with every single choice you make, and then trusting that over the long run, the laws of probability will deliver the results that your superior process has earned.
So, I'll leave you with this question to chew on. After everything we've just covered, what's one decision in your life right now, could be big, could be small, that looks completely different when you look at it through this new probabilistic lens?